Hello, this is a video solution to this sample problem, this conservation of momentum sample problem. Here's the problem. A 76 kilogram boater, initially at rest in a stationary 45 kilogram boat, steps out of the boat and onto the dock. If the boater moves out of the boat with a velocity of 2.5 meters per second to the right, what is the final velocity of the boat? This is when typically Andrew would come to the board and draw a picture of a person stepping out of a boat to the right onto a dock. So if you want to pause this video and go find Andrew and ask him to sketch this out onto the whiteboard, that would be excellent. That would make me so happy. In fact, if you would take a picture of it and somehow post it, I'm going to open up a discussion on the home page here of Canvas, and I'll link a way that you guys can share a picture of Andrew drawing this up on the board. That would bring a smile to my face. Now, once you're done pausing the video and ready to move forward, we'll move forward. We're going to talk about what we know first. What we know are details about the person. Whoops, I didn't really intend to do that. I wanted to, sorry, little technical issue. There we go. We know details about the person, and so I'm going to put like m sub p means the mass of the person, and the v sub p means the velocity of the person initially, and then the velocity of the person finally. So the details about the person are a mass of 76 kilograms, initially is at rest, a velocity of 0 meters per second, and a final velocity of 2.5 meters per second to the right. What do we know about the boat? Well, we know that Andrew drew it quite well, and we know that its mass is 45 kilograms, and its initial velocity is 0 meters per second, 0 meters per second, period. I don't know why I stressed it the way I did. Now, we are solving for the final velocity of the boat, and we're going to draw that as v sub bf. Okay, so velocity of the boat, final. That's what we're trying to solve for. To do that, we need to there, I'm going to move this uphill here. To do that, we need to remember that there's an equation that will help us do this. So we're going to choose an equation. Because the total momentum of an isolated system remains constant, the total initial momentum of the boater and the boat will be equal to the final total momentum of the boater and the boat. So that's our clue. That will let us use this conservation of momentum equation. There it is, the momentum of the person at the beginning plus the momentum of the boat at the beginning equals the momentum of the person at the end plus the momentum of the boat at the end. This is it. We know the mass of the person, and we know the initial velocity of the boat, of the person. We know the mass of the boat, and we know the initial velocity of the boat. We know the mass of the person and the final velocity of the person. We know the mass of the boat, and we're solving for this very last variable. That's it. So we know everything except for one thing. Easy, easy to solve this. So here's how we'll do this. Whoops. We will, because the boater and the boat are initially at rest, the total initial momentum of the system is equal to 0. So this whole left side equals 0 because the velocity of the person is at the beginning is 0 and the velocity of the boat at the beginning is 0. So we don't have to put all these numbers in. We just know this left side is all 0. Therefore, the final momentum of the boat, of the system, must also be equal to 0. So we can rewrite this equation up here like this. The momentum of the person times the mass of the person times the momentum of the person at the end plus the momentum of the boat times the velocity of the boat at the end equals 0. Okay. Good. Now we're going to rearrange this formula to solve for the final velocity of the boat. Rearrange the equation to solve for the final velocity of the boat. Here's what it looks like when it's rearranged. There we are. Down there. The mass of the boat. Well, this is in the process of rearranging it. I subtracted the momentum, which is both these terms multiplied together. I subtracted the momentum of the person from both sides of the equation, and this is what I get. And now I'm solving for final velocity of the boat, and that by dividing both sides by the mass of the boat. And so when I do that, I get the final velocity of the boat equals the mass of the person times the velocity of the person at the end divided by the mass of the boat. I know all those numbers. Everything, all the algebra is done. It's just a matter of putting the numbers in and solving it. So I did put all the numbers into the equation and solve it. So the mass of the person is 76 kilograms. We have to remember the negative sign. We're multiplying by 2.5 meters per second to the right. We're dividing that whole thing by 45 kilograms. And our answer is going to be negative. So let's know what that means. It's negative 4.2 meters per second to the right, which is kind of an odd thing to say. That's sort of a weird way to describe that. The negative sign for the final velocity of the boat indicates that the boat is moving to the left in the direction opposite the boater. So it's moving negative 4.2 meters per second to the right, or you could, in a more human way to describe that would be just 4.2 meters per second to the left. That's it. Okay. I hope that helped. Go be awesome.